All right, here's some practice problems from 10.3. I sent out the video this morning on the notes and also your quiz. We won't be doing quiz today. We'll be moving that to tomorrow. So for your 10.3 ones, I picked out a few of them, a couple from the back page that we always have troubles on every year. We'll do number 4 first, where we had to figure out the percent composition, or in this case, we actually had to figure out the mass of each of our elements in this compound. So we had to do it a little bit differently, so that's why I picked this one out. So we got carbon, we had hydrogen, we have nitrogen. Okay. They tell us that we have 66%. I need to grab my book so I don't keep turning around. 66.07% carbon. And we got to turn that into a decimal number, so let's divide that by 100%. That gives us our decimal equivalent. That'll get rid of our percentages. And it tells us in the problem that we have a total of 2.876 grams of this substance. And of that substance, 66% of it is carbon. So when you plug this into your numbers, we know we're going to get 4 sig figs. We come out with an answer of 1.896 grams of carbon. Okay, so that's the only units that we have left, carbon and grams. We do the same thing for hydrogen. In this case, they said we had 6.71% hydrogen. Again, get rid of our percentages by writing it over 100%. We still multiply it by the same exact value. And when you plug and chug on this one, you get 0.19297, which is way more sig figs than we can have. We can only have 4, but I went more because after the 4th one, we got a 7. 7's going to raise this up, so this actual answer becomes 0.1930 grams of hydrogen, and that's the one that we circle. It's like we circled that one there. Now, you can do 2 things at this point. Some of you may have figured this out. If you're figuring out 3 parts to something, we can add these 2 parts up and subtract it from 2.876, or we can run through the same process and get the value. Okay, and we'll do the same process and get the value. 4.06% divided by 100%. The percents cancel out. We multiply that by 2.876 grams of our whole substance. And this one I'm going to round off 2 because it comes out at 0.11676. So again, we can only have 4 sig figs. So 1168 grams of nitrogen. Okay, so again, could have subtracted these 2 from 2.876 and got this answer, or you could just run through the process. And again, you'll be able to run through that if you've been working on these problems today and tomorrow. You can practice those things and figuring out what's your missing 3rd one, or your 4th one, or your 2nd one. Okay, as long as you figured out most of them. Okay. Our next problem is going to be number 10. So again, if you need to, go back and rewatch that. It's pretty straightforward. Some of them, other examples really quick off this. Sometimes they give you the total amounts. Like they give you 10 grams of this, 5 grams of that, and 8 grams of this. Then it says, what's the percent? You guys know how to do that. We figure out your test scores all summer or all school year long. And it's the same thing. You take the part that you got, divided by the whole amount, times 100, and that gives you your percentage. So you've done that many times, not just in this class. So let's look at number 10. And we're actually looking at an empirical formula, first time, or second time, I should say, doing this on a board. Number 10, it wants to know what is the empirical formula for a gold chloride chlorine compound. So it tells us that we have 2.644 grams of gold, AU. Okay, and it also tells us that we have 0.476 grams of chlorine. So we have to get molar equivalents to compare these. We can't compare apples and oranges. We got to compare oranges to oranges or apples to apples. So let's turn that into the one unit that we can compare them to, and that's the mole. So we know that 1 mole of gold is equal to 197 grams of gold, and we get that right off the periodic table. 1 mole of chlorine is always 35.5 grams of chlorine, which we established a long time ago. Grams cancel out, grams cancel out. This gives us a molar equivalence of 0.0134 moles. And we get the exact same number right here. So, according to our notes, we divide by the smallest value. Well, this is our smallest value. So if I divide each of these by that same small value, we get 1. We get 1. They cancel each other out. So we know that the formula for gold chloride is AuCl. And that's our answer. And then you got a whole bunch more of those to do, or you should have done. Okay. Again, if you have any questions on any of the specific ones, email them to me, guys. I'll get right back to you. Those of you that are doing that are finding out that I answer you pretty quickly. Okay. That's number 10. The next one I want to do is an oddball one. And it's mostly due to syntax. It's due to how they wrote the problem. This is going to be problem number 21. Some of you may have had a question on 21 because of the way they ask it. I'll even read number 21 off because it is one that comes up almost every year as a problem.
Just a second. I need to hit pause for a second.
So we're going to look at number 21 because it comes up all the time. It says octane, a compound of hydrogen and carbon, has a molecular mass of 114.26 grams per mole. So it tells us its molecular mass. So we're not quite doing molecular formulas yet. It's telling us that molecular mass. Then it says 1 mole. So we're only dealing with 1 mole of the compound. So for this problem, 114 is the maximum amount of mass that we're going to have. So it tells us we got 1 mole of this substance. 1 mole of this, it tells us that hydrogen is 18.17 grams of this substance. Okay, so that's pretty easy because I can then subtract that right from 114 and you get 96.08 grams left over. Well, that has to be our carbon because all hydrocarbons are just carbons and hydrogens. So we know that, well, if 1 mole of hydrogen is also 1 gram of hydrogen, we know that the molar mass of this has to be 18. Okay, grams cancel out. So this is going to be 18 moles. For carbon, we know that we have 1 mole. And again, we're dealing with only 1 mole. This is gram per 1 whole mole. So 1 mole of this divided by 12 grams of carbon gives us a total of 8. So we know that the formula for this is C8H18. What a lot of times happens on this one is that you'll get to this point and then you divide by the lowest value, which we do for our empirical formula, and then it goes haywire. Okay? We don't do that on problem number 21 because it's already given us only the molecular mass and we're only dealing with 1 mole of it. So when you calculate this, you're actually calculating the actual number of hydrogens in the compound and the actual number of carbons in that compound. So that's the right formula for octane, which you guys can go back in your notes and look it up. When we talked about hydrocarbons, there it is. It's already in your notes somewhere. Okay? And then that brings us to our last problem, which is, again, the last problem on the worksheet, because everybody always thinks the last one's the hardest one. Okay, this one is taking an empirical formula, or finding the empirical formula, and then finding its molecular formula. Okay, so this is number 25. It's a really good problem, by the way. It's one that is a good example. It's very similar to the one that we did in your notes, too. In this one here, we are looking for the formula for a phosphorus and oxygen compound, given these values. We have 56.36 grams of oxygen, and we have 43.64 grams of phosphorus. So the first thing we have to do is find the empirical formula for this compound. And to do that, we get our molar equivalents. Okay, so we know that 1 mole of oxygen, 1 mole of phosphorus. We look up on our periodic table, 16 grams of oxygen per mole. And phosphorus is 31. Let me double check. Yep, 31 grams of phosphorus. Again, always check your periodic table. Grams of phosphorus cancel out. This gives us our molar equivalent. In this case, we get 3.5 moles and 1.4 moles. So we do what we are supposed to do when we get the empirical formula. Divide by the lowest value, 1.4. Divide by 1.4. It's always a good thing. It's not a bad thing to write in there. I know what you're doing if you put that in your work. And this gives me the total number of moles here is going to be 2. Okay. Sorry, hold on, guys. Sorry, guys. Gotta go back. I'm looking at the wrong problem. Looking at the wrong set of my problem.
I'm going to hit pause for... Oh, you ready? Okay. Sorry.
Okay, this should be 2.5. Sorry, guys. And this one should be 1. This is that one I talked about in our notes really quick that, hey, when you come across this, it's just like when we do a coefficient. If we get a 2.5, a 3.5, a 1.5, we don't round it up and we don't round it down because we're right in the middle and our precision will be way off. So when we get to a situation like this, we multiply both of these by 2 so that we can get a whole number. So this becomes 5, and this one becomes 2. And because this is an ionic compound, the more positive phosphorus goes first, so this becomes P2O5. Okay, so I know some of you got to this point and you rounded it up to 3, and then things probably went haywire from there. But in this case, if we get a 2.5, we always multiply it out just like we do in our coefficients. So this is our empirical formula. That's our empirical formula. Well, it wants to know what's the molecular formula. Okay, we want to find molecular formula.
You have 2 minutes.
Okay, to do that, the molecular formula is always going to be the given value, which they gave us, which was 283.4 grams per mole, divided by the total of this, which comes out to be 142 grams per mole. And this gives us a multiplier of 2. Okay? So then I apply that to my equation, and the molecular formula is going to be P4O10. And that's the right answer. So you have to get your multiplier by taking the molecular weight divided by the empirical weight. If we do that, we get our multiplier. We take our multiplier to our empirical formula, we get our molecular formula. So that's how we do problem number 25. Again, sorry I got messed up on that top part there. But keep working on those things. Email me if you've got questions. Talk to you later.